Welcome to a new test and teardown video. This time it's another Impo Power Supply, a triple DC power supply type 1146. I just got this at a local flea market, kind of cheap, and he said it's working. I've been cleaning and cleaning here. People got a very, very bad habit of putting all sorts of stickers and labels and shit on the front. I mean, please, why don't you put it on the top or on the back or something? Why do you always want to have labels in the front? I really hate it. I like the fronts to be nice and original. And I don't want people to scratch displays and stuff like that. See? There are some really nasty scratches here on that one. But it's, I think it's just 3 individual power supplies. You can put them in series or parallel or whatever you like, of course. And you got individual voltage and current setting. And the meter can be voltage or current. So all that looks pretty identical here on all 3 of them. Except this one is less voltage, more current. So that's all there is to it, really. Let's look at the back if we see anything fancy. Okay, so that's all. Not a lot. In the good old days, we had 220 volts. So of course this reveals it is quite old. And 225 watts. Yes, of course, this is a linear power supply. So there will be a lot of loss, right? And here we find the heat sinks. The bottom chassis, probably a thick aluminium profile and bent all the way here. It's a little bit untraditional to have it here in the bottom, but doesn't really matter if you put them on the back as long as you got plenty of area. And I think we're ready for the first power on. Click. Okay, so it's full of relays. Nice bright lamp for power. That is good for safety, so you know if it's on or off, of course. And okay, that is how we want it. Yeah. Oh, 2 relays. Okay, we got 2. And this is a very, very good idea when you're designing linear power supplies to have different taps of the transformer and then use relays. So that means you have very little voltage drop on your series regulator transistor. So all this. Yeah, oh, they even go to 0. I actually really prefer it to be like that. So when you go all the way to 0, then yes. And this one's probably not with the clickety. It says 0 to 5 volt, and it actually goes to 6 unloaded, obviously. So I expect this one to be able to give 5 volt when it is loaded. How about we try if it works? There's actually a thing I want to show you about the voltage output here. So if you look at the voltmeter, I'm trying to adjust very close to 0, and then try to see, oops, and then slowly try and take it down, and then oops. So see, it's more or less impossible. What is this one? This is the first. Anything under 0.5 volt or 1 volt is like very, very critical to adjust, because it's in the first quarter of nothing. But then after that it goes quite easy. See if we set the first one for 6 as accurate as we can. And it is almost 6. Of course, a meter like this is not a reference equipment. So 6 is a little bit low. Let's try 12. Okay, 12.6. I mean, and then if you want to use what, 24? Let's see. I'm gonna be sure not to put it too low, but let's set it like this, right? Huh. Almost. Ah, that is too low. I should be able to adjust that. So this is what I want to adjust. All of the outputs actually do the same thing with this low voltage thingy here, where it's insanely critical, then there's nothing, and then there's something. And this has just something to do with the design. And this one is supposed to do 5 volts and 3 amps. Let's do that. Give it full screw and 30. Ooh, that's supposed to do 30. That one is supposed to do 30. So I got 28 as my max, 28.9, and that one is doing 5. Okay, so let's try and load this as at maximum. Max voltage, max current at the same time, right? I'm trying to play a little bit with the amps. So that was only 1 amp. And look at that. That is not 1 amp. So this definitely is due calibration. What do you know? And that is 1.5. It should be here, right? It's way too low. And that is 2 amps. Okay, so here we go, 28 volts and 2 amps, so that's what, 56 watts. So let's take the next one and see if that is the same kind of problem. Current, I said current. Okay, so there's, ooh. What is this? Okay, that one we need to fix. Maybe it's the same. Okay, that is totally... So... But it's not affecting the output at all. This is only a metering issue. I'll see if I... Okay, so it's probably also the same with the readout. Okay. Great. Let me fix this. So that is 1 amp, and let's give it... No, it is not 1 amp. Now it is 1 amp. And then it's actually quite accurate. And then it's 2 amps. Okay, let's do the last one. 5. Enable current 1 amp. Hello? No? So it's not working. What kind of crap is that? But I got 1 amp. Right? So I got all the watts, but not a lot of metering here. Nope. Okay. And let's see if this one can do 3. 1, 2, 3. And then the... Okay, let's see if we can go to volts. Okay, almost 6 volts at 3 amps. So now we got 17 plus 57 plus 55, right? And then how much are we using on the mains input? 240. So let's look a little bit on the results. I did a little bit of paper math. So this is our input power and the 3 output powers we got here. So we can add this and divide it by this, and then we got 75.6. Sorry, I need to look at what I'm doing here. So that's actually quite a high efficiency for a linear power supply. And then we got 109.6 watts of loss. So that will of course heat it up a little bit. It's not that that bad really. It's, you know, compared to the size, this is really big. If you see here how big it is, but it's a really beautiful with the lights in the meters and all that. I just need to fix the amp meter here and the switches and all that kind of stuff. So let's look inside. I have shown you a lot of Impo products before, right? And some of them look like escaped prototypes, but this one is really beautiful. Okay, if you just pretend the white wires and all that kind of stuff here is not here, because that is not original. This is an upgrade performed by some student or something, right? Just to add some really nice light to all the meters. But if you subtract that, then the rest here is, look at that, super beautiful. And it's the same power supply board they're using in more or less all the different models. And see this mounting. This is the main power regulator that is supposed to be mounted on the bottom plate. And that's exactly how it is done using this piece of PCB. And there's actually a few things here that's made correctly. See, if you look from the rectifier diodes, then the signal goes to the capacitor and then to the rest of the circuit. I mean, that is definitely how you want to do it. So this reveals they know what they're doing. Great. There is a little bulb down here. I will kind of swap it around so you can see it. Oh, that's extra bulbs in a little bag. So the guy that made this little light upgrade thought about, what if those bulbs don't last forever? And this is a classic Impo sticker that reveals the production dates. Don't you just love it? 95. So I think those bulbs, they're actually load. It looks a lot like they're connected directly to the output. And this one is also blown, so this one don't work as well. And look at all the debris around this area. And I'm a little bit worried about the distance. Here is, can you see that? Is not a proper safety distance. But this power supply actually works as well. But I don't like this kind of debris here, so I definitely need to fix this. And remember, there's definitely no readout whatsoever in current mode here. So I need to find either, I don't know, I need to figure out what is broken here. And both of these are just so bad. I think I'll just change them to new ones and then see. I really like the color-coded wires. So this is definitely what you want to do if you're making stuff like this. Use different colors and then do exactly the same with the next and the next. Can you see how smart that is? Now I can change one of them and just look at the others and then do it right. Ha! I love it. Also the same with the colors for the meters. This of course looks a little bit like done a little bit too fast. A big heavy transformer. And those capacitors, they are also mounted real good and all that. And mains entry is also done correctly. Yeah, I'm actually quite happy about it. And this is welded and extra strength and stability. So yeah, good and great. been trying to clean all this debris up, and I think it's actually working. Gravity is my help in this case. So far so good. But when I'm doing all my investigations here, I also do see a little bit of funny things. Like, what do you call this? Solder drip drops. This should have been seen when you're like soldering this and then you go somewhere else and then splat. And it's actually the same here. Somebody's soldered, they were soldering these two wires here, right? And then look at that big blobbity drop. It landed right there. So what happens when this, see? When this one goes loose and it just fly around in this box, it's gonna create some sort of a reliability issue, or it's just gonna kill the product. I mean, you need to do a little bit better than this. You can't leave all sorts of metal parts flowing around, and this is definitely a potential thing. Look, how much do I need to push this? Normally you don't need to push them. This is actually, yeah, here we go. And then flippity floppity around the product, and then you're gonna have short circuit splitsy blitsy all the way around. I'm not impressed about that kind of stuff. This is not how we do it where I come from, I'm telling you. So I'm trying to restore the current sense here, and I'm playing a little bit with the first one here. While I was removing the bulb, I kind of broke the track here. I was trying to remove the bulb from the top because it was just totally in the way. So, and there's no bulb in the others, and it's broken anyway. So, and it was a little bit in the way from the output here. So, what else did I learn? This PCB here is called 1141, and that is the model number for this PCB. And I believe this one is the week and the year. So this PCB was made a little bit before the complete unit, because you see that actually matches a little bit. Now I'll try and see if I can find another switch for the voltage current setting. When I have this board out like this, I should probably also change this tantalum here on the output. I kind of don't like that. And what is that? Okay, it says 35 volts. Okay, whatever. Oh yeah, did you see this? The layout, the tracks from the output. So it's definitely sense feedback and all that kind of stuff. So it's actually quite well made. It looks a little bit like this Letraset hand-drawn layout, and it's really beautiful. Can you imagine doing this on a transparent film by hand? It really looks like that is the way this was designed. And then UV developed and all that kind of stuff, hand drilled of course. And just like the cases, they also contain all those marks and stripes for where to drill the holes and all that kind of stuff. It's definitely handmade, all of it. Yes, you can see some. Oh, it's not that easy to see on this one, but normally I see all those lines and such. Yeah, here we got. And it goes all the way. It's probably trying to figure out, hey, where to do this and where to do that. Maybe, I don't know. So that was easy. I just replaced the switch and see, voltage, current, and then it's super accurate. I of course calibrated it a little bit. So this is 1 amp. Let's try and see what happens if it's linear. So this is 1, 2, and 3. Okay. Ooh, it's moving a little bit. 2 and 1. So let's turn off the current and then voltage is 4, and it is about 4. So here is what I did, just in case you got one of those power supplies. You may want to know, oh, this is difficult to see. See, this is the voltage and the current calibration of the readout. No matter how you turn in this, it's not going to affect what is going out. And there's actually one last word to say about this type of power supply. This board do not contain a discharge resistor or a bleeder resistor for the main charge capacitor. In this case, we got all the bulbs mounted on this capacitor, so it's not a problem in this power supply. The other two power supplies, as you can see here, the main storage capacitor, there's no discharge resistors at all on this PCB, and that means this one will stay charged for a very, very long time. And it is only a problem for you if you want to do service in here. You're going to get a big shock if you don't check this or discharge the capacitor. So why didn't they put a discharge resistor on this capacitor? It's because this sort of power supply contains a little auxiliary power supply using this little bridge rectifier capacitor and some resistors and op amps and whatnot. And when this capacitor is discharged, the output goes to 0. See if there's voltage out here. We turn off the mains supply, and then output goes to 0. That has nothing to do with this one. Oh, this is still goody charged. But as long as this one is not charged, it looks like it's 0 because there is no other switch to turn on and off the outputs. So when you're playing around with your circuit and, oh, I want to have my voltage back, you just turn it on again using the main power switch, and that means the peak currents in the entire system is within limit not to eat this switch. So that is the design idea of having those like pre-charged. So it's only the first time a day the peak current will be very high, and it will eat a little bit of lifetime from this switch. I really prefer to have an output enable disable switch or something like that, or a little switch somewhere so you can turn on and off your output and then let the power supply remain powered. Like if you take any other modern power supply, just a random one like this, see, you got output on and off, and then the power supply is showing whatever is the setting and whatnot, right? And then you have your on and off, and if you got more outputs and more stuff going on, oh, you can of course turn all of them on and off. This is how it should have been done, and it wouldn't have cost a lot of extra money. I think it is what you should do if you are upgrading a power supply like this. So anyway, thank you very much for watching. Have a good day and see you tomorrow. Bye bye.